Right. See? Jaeger brother. Right. Now I think it. Listen. These are blast. These are blast. Right? These are blast. And here this is a funnel with the tap. This is a funnel with a tap. This is a funnel with a tap. Right? A funnel with a tap. Right. Right. See? And to this end, the capillary tube is connected. To this end, the capillary tube is connected. Right. And here we have a manometer. Manometer. Manometer is a pressure gauge. Manometer is a pressure gauge. Manometer is a pressure gauge. Right, this is a manometer. Manometer is a pressure gauge. Right, and here this is the liquid that we are going to find the surface tension of. Right, and here we have a bent pin. Right, there is a bent pin, and here. Right, we have to have an adjustable table, right? Height adjustable table. Adjustable means height adjustable table, right? Height adjustable table. Height adjustable table. Right. So, funnel with that. Funnel with a tap. Right, and this is a blast. This is a blast, right? And this is the manometer. Manometer is a pressure gauge. This is height adjustable table. Height adjustable table. And this is a bent pin. Bent pin. Bent pin. Right? And this one is a capillary tube. Capillary tube. Right? So in the manometer there are second liquid, right? There are liquid that here, that is for the manometer liquid. Right? This is manometer liquid. Right. Let's consider height difference of the manometer liquid is simple H, and density of the manometer liquid is say sigma. Right. Height D here. Height difference of the manometer liquid say D. And height to the bottom of this from here say H, and density is rho. Right. Now listen. Oh. That's okay. Okay, listen. Okay, listen now. Jadi kan? Listen. He's a competitive. He's a competitive, right? Competitive. And here, before we insert this tube into this liquid, a bent pin is attached here. A bent pin a bent pin. Right? Is attached. Right? We attach that to here. And then height of the table is adjusted until this end of the cover tube is immersed in the liquid. And as the bent pin just touches the water surface, what I mean, the liquid surface here, right, in the vehicle. I make a touch and make a just right. And now we have a confined air inside this tube. See, we have a confined air inside this tube. Right? We have a confined air inside this tube. Right? In the end, right. We have confined air inside this tube. When the tube is confined air, that is not open to atmosphere. Right? Now, what we do is we are opening the funnel. Right? When funnel is open, these four droplets from the funnel are adding with this right? When it is added, volume of water increases. When volume of water increases, volume of the gas medium decreases, so pressure increases. Right? It is going to increase pressure. Then this pressure is right transferred to here and here as well. Right? Because of the additional pressure, the pressure is volume increases. When that volume increases, volume increases, volume of water increases, volume of gas displaces, it decreases, and it displaces toward this side. The gas molecule, then this will be pressurized. When that is pressurized, there is a liquid meniscus forming here. And the liquid meniscus, right? If you take an enlarged view, right, a magnified view, right, make a view better. Now at the edge of this tube, right, there is a liquid meniscus formed like this. Right, combining over movement, right, combining over movement, now it will be initially like this, and then radius gradually decreases, and it is reaching its maximum. Right, when radius of meniscus equals radius of tube, right? Unnamed point now. I name meniscus. You must name and never radius reduce. Now, I have point now. Right, that point is the maximum point. Maximum point taken. So at the maximum point, it looks like this. At the maximum point, since radius of meniscus and radius of tube are equal, the meniscus is exactly hemispherical, and the meniscus is like this. Meniscus, right? And if you increase pressure further, this liquid meniscus is going to explode. I don't know. That is going to break. That is going to explode. Right? Pressure, why do you know? Because it is going to counterbalance pressure by it equals 2dOr. Meniscus again 2dOr. Right? 2dOr. If that pressure is not bearable, that is going to explode. It will explode. Right? Explode which then may liquid right. Now, by slowly adding water into the flask here, right, we have to obtain this occasion where the maximum pressure difference occurs the pressure is right. A maximum mega it breaks. Right. If you just go beyond that maximum point, it breaks. Right. Mega identify because for the first time you are going to get this at once, right? It explodes. When it explodes, we have an idea what was the difference of liquid levels in the manometer. Then we know that this is going to explode somewhere around 4 centimeters. Then when that is closer, we are slowly releasing this and identifying this scenario. Right? Right. Let's assume pressure inside the meniscus as T1, right? Pressure inside the meniscus as T1 and atmospheric pressure as P0. This is open to atmosphere, P0. This is also open to atmosphere, P0. Right? If pressure inside the meniscus is P1 and if pressure outside the meniscus is P2, right? To write pressure inside meniscus, you can get into the system through the manometer, right? P naught plus d sigma g, right? But sigma d sigma g equals pressure at this level. That is equal to same horizontal level. That is equal to this medium here up until here. Right? And rubber band up until here. Right? Then P1 is P naught plus d sigma g equals P1. Pressure inside meniscus. To write pressure outside meniscus. Outside meniscus can be right. Then P naught plus simple H rho g. Then P naught plus simple H rho g equals P2. Right. Here we are. Now we know pressure difference across the liquid meniscus. Pressure difference across the liquid meniscus delta V is given by 2D over R. Right. Pressure difference is pressure inside minus pressure outside P1 minus P2. Then P1 minus P2 equals 2D over R. P1 is here. Right. P naught plus d sigma g minus P naught plus H rho g. H rho g. Right. Equals 2D over R. P naught 2, P naught cancels. Right. G is common. G is common. Then d sigma minus H rho equals 2D over R. Then T is given by GR over 2 d sigma minus H rho. Right? G is known. Right? R is now equal to radius of tube. Radius of tube should be determined later on. Right? Using a traveling microscope. Right? Traveling microscope का use करला अराको हुआ करने लो. Right? Using a traveling microscope, later on we have to find the radius of tube. Right? एक बार पुलों. G is known. Right? G is known. एक बार पुलों. The density of manometer liquid is height of manometer liquid is known. Density of manometer liquid is known. These two are known. This means they can be determined. Right? This is the most accurate method to find accurate, and there are some other lyrics also to find surface tension of liquid. Right? This is not only limited to these kind of liquids, right? Even for something like mercury, this is also still possible, right? Right. Right. Okay. First mention materials. First mention materials. Materials. Right. Mention Jaeger's apparatus. Jaeger's apparatus. Jaeger's apparatus. Jaeger's apparatus. A beaker. A beaker. A beaker. Then a small amount of kerosene. A small amount of kerosene. Kerosene that one have one. A small amount of kerosene. Kerosene no water. Huh? What's the color of kerosene? Huh? Red. Right? See that no? Ada blue dia, blue dia lagi. Blue dia lagi. Oh, green. Green. Red dia ni, blue dia. Blue dia. Eka. Ada blue dia also. Right? Okay. Then the liquid of which next one, the liquid of which surface tension to be determined. The liquid of which surface tension to be determined. Then traveling microscope, a traveling microscope, a traveling microscope, a traveling microscope. Next, funnel with a funnel with a මේ funnel එක කොහොමද term එකකුත් තියෙනවා. මොකද term එක? ඔයාලා ඉස්සරහට use කරනවා. visual funnel කියලා එකක් කියනවා. දෙමළයි. ඕනනම් visual funnel කියලා ලියන්න පුළුවන්. right funnel විතරක්. funnel විතරක්. right. Then height adjustable table. 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 Okay, now take out the apparatus. Take out the apparatus. Height of the product carry. Right? Better over. Face it. Apparatus camera. Jadi apa ini kan? Andai aja. Ya. Boleh. Ya. Terus. Ya kan? Baik. Saya balikan ini kan? Oke. Perlu theory. 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 No need to draw this here. Make I'm going to draw this here. Right, here, right down. Let pressure inside. Let pressure inside. Meniscus. Left pressure inside meniscus. BP1, BP1, and that outside, and that outside, and that outside, P2, and that outside, P2, right? P1, right? Put it on, and start here. Start here. From here, start from here. Start from here, and let's say up to here, that is what. Okay, then method, method. First point, find out. First point. Capillary tube should be very clean. Capillary tube should be very clean. Capillary tube. Capillary tube should be very clean. Capillary tube should be very clean. Right. What are the steps of cleaning a glass tube? Washing with sodium hydroxide, then HCl, then distilled water, and well drying. Right, paste the other here on substitute the game over here. Right, 28 days. Substitute the game over here. Right, mention these four steps. Right, first one, wash with sodium hydroxide. Base we have to mention the base, right? Wash with sodium hydroxide. Wash with sodium hydroxide. Second one, wash with HCl. Wash with HCl. Third, wash with distilled water. Wash with distilled water. Distilled water. Four, well drying. Well drying. Well drying. Well drying. Right? Wow, maybe more now, have I considered any angle contacts? No. This is very clean. Then we can make sure that there is no angle contact here. Right? You can angle the angle contact out. Right. Next point. Next point. Bend a beam. Bend a beam. Bend a beam. Bend a beam. Bend a beam and attach it to. And attach it to. And attach it to. Attach it to. Capillary tube as shown. And attach it to capillary tube as shown. Attach it to capillary tube as shown. Right, within brackets. Around 3 centimeters above. Around 3 centimeters above. Around 3 centimeters above. Around 3 centimeters above. Right, next point. Fill the beaker. Fill the beaker. Fill the beaker. with the liquid. Fill the beaker with the liquid, of which fill the beaker with the liquid of which capital T to be determined, capital T to be determined, and keep it on, and keep it on, and keep it on height adjustable table, and keep it on height adjustable table, and keep it on height adjustable table. Right. Next point. Adjust the height of table until 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 bend pin bend pin bend pin just touches the top surface of liquid, just touches the top surface of liquid, just touches the top surface of liquid, just touches the top surface of liquid. Next point. Open the tap, open the tap, open the tap, and let water falls into the flask. Open the tap, open the tap, and let water falls into the flask. To increase pressure inside system. To increase pressure inside system. Do this until the liquid meniscus is exploded. Do this until the liquid meniscus. Do this until the liquid meniscus is exploded. At the end of capillary tube. Alright, next. Repeat again. Repeat. And identify. The occasion when. Identify the occasion when. Pressure is maximized. When pressure is maximized. And get the respective. Height difference of manometer liquid. Respective height difference. Within bracket simple D. Respective height difference. Within bracket simple D. Of manometer liquid. Right. Within brackets. Can repeat again and get the average value. Can repeat again and get the average value. For more accurate rating. Right, and D sigma is known, right? The other thing is finding H known, right? HRMI to find H, right? After doing the experiment, you have to remove this beaker, right? Beaker. After removing beaker, Right? We are focusing the traveling microscope to the bottom edge of the spin and taking the reading. Right? මේ pin එක දැන් ගහලා තියෙන්නේ. මේ pin එකේ මෙතනට focus කරනවා and taking the reading. And then it is focused again to the bottom end of the capital radio and taking the reading. Difference between these two is the height here. pin එක ගහගන්න ඒකට. Right? pin එක නැත්තම් ඔයාලට මේ height එක වත් කරගන්න දෙයක් නැහැ. Got it? That's why the main pin is connected. ඒක වාසේ කරන්නේ. මේකේ දීති readings ගන්න බෑ because due to refraction there will be errors. මෙහෙම දීති නැත්නම් focus කරන්න බෑ. මෙහෙම දීති focus කරන්න බෑ. Otherwise if you try to focus the microscope through this model here, right? There are errors of the reading due to refraction of light. Right? ඒක මේක අයින් කරලා then once this is removed we have a very setup. Right? මේක දෙනවා. After everything is removed then focusing microscope here and taking the reading, right? And focusing into the edge of the table, edge of the tabular view, and taking the reading. And difference between these two is the height view, right? Take a microscope. And not only that, we need the radius also. Radius and diameter also. Then to find the diameter also, right? We have to we have to fix this in front of the microscope and get the internal diameter. The color microscope use kar. Right? Then remove the beaker. Remove the beaker. And focus travel microscope. And focus travel microscope. And focus travel microscope to the bottom of bent pin and take the reading. To the bottom of bent pin and take the reading. And to the bottom of capillary tube. And to the bottom of capillary tube. And take the reading. Difference between these two gives simple H. 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 Right. Next point. Fixed capillary tube. Fixed capillary tube in front of traveling microscope horizontally. In front of traveling microscope horizontally. And get the internal diameter. Right? Take that in mind. To get internal diameter, right? First you have to focus the cross wires here. Take the reading, say R1 to here, R2, right? It was done. Then to here, say R3, and to this point, say R4, right? Vertical diameter is right. Vertical diameter is B1. Vertical diameter is R2 minus R1 minus R2. Horizontal diameter is R3 minus R4. Right? Then diameter of this tube is D1 plus D2 over 2. Take this down. Right? Diameter of R1 told. But where is it? right? Next point. Calculate, calculate, calculate. Capital T, calculate capital T as discussed under the area. Calculate capital T as discussed under the area. Calculate capital T as discussed under the area. Right. That's it. Right. And remarks. I don't know, remarks. Right. I did remarks. Why are they? Okay. Right. Remarks. Remarks. First point. This method can be used to. This method can be used to. This method can be used to study variation of surface tension with temperature. This method can be used to study variation of surface tension with temperature. With a relevant modification. What modification है? Whether the Bunsen burner can check करा or not make different temperatures लगाना. If you need to find this at different temperatures, T at different temperatures, right? Using a Bunsen burner, you can do the same, right? You can even the same. There are variation in surface tension other T and theta, right? Decreasing in the increasing rate, right? Sorry, decreasing and increasing rate. अन्य variation in करना बोलो, ये variation in करना बोलो, right? And next point. A liquid with lesser density is used for manometer. A liquid with a lesser density. A liquid with a lesser density. A liquid with a lesser density. Within brackets, like kerosene. Kerosene not density is 700. Right? Like kerosene. To get a considerable height, to minimize percentage errors, right? Next point, capillary tube should be well cleaned. Capillary tube should be well cleaned. Capillary tube should be well cleaned. As to neglect angle of contact, and make the liquid meniscus clean, and make the liquid meniscus clean, and make the liquid meniscus clean, and make the liquid meniscus clean. Okay, right? That's it about Jaeger's overload. Any questions? Right? Then I did these two for a reason, right? Last two I did these two for a reason, right? And I got right? Last two. Any questions from anything we discussed today? Any questions? Anything? Last. Right seminar. You are heading for the event, right? පස්සේ આવුත් ගන්න නැහැ ඉතින්. පස්සේ හරි නෑ කොහාට. කියනවා කියන්නේ නෑ. මම කියන්නේ දැන් ආයෙත් ඉගෙන ගන්නවා ඉවරයි. Anything? All right. Any questions? Any questions? Right.